Alright, so we're looking at finding critical points and relative extrema of f of x using the graph of f prime of x. So those are the two things we're doing today. But before we get to that, we want to look at the graph of f of x and understand what a critical point is and what relative extrema are. Okay, so the first thing we need to do is start with the critical point. Critical point happens when one of two things happens, and you need to write this down. The critical point happens when f prime of x equals 0 or when f prime of x is undefined. So the two ways a critical point can happen. When f prime of x equals 0 or when f prime of x is undefined.
Can f of x have a critical point?
It is the critical point of f of x, and that's how you find it, is using the derivative.
Okay.
So we're going to use, because remember in calculus, we talked about this either last week or the week before, we never use f of x to talk about what? F of x, and we never use f prime of x to talk about f prime of x, and so on. So what we're using is, we're using f prime of x to talk about f of x. So it's a critical point of f of x, and we're using f prime to find the critical point. That's what we're doing. Okay? So the critical point happens when f prime of x is 0 or when f prime of x is undefined. Now, let's talk about what that would look like graphically on f of x. Okay? So, let's do the first one. When f prime of x equals 0, what will that look like graphically on f of x?
Is this f of x?
X-axis.
We're showing you f of x, and I'm asking you what is going to happen on the graph of f of x if f prime of x equals 0.
It touches the x-axis.
What does?
F prime of x.
F prime of x would.
F prime of x touches it? I thought F prime of x was the x-axis. No, 0
F prime of x.
is the x.
If you're looking at the graph of f prime of x, it will equal 0 when the graph touches the x-axis. But we're looking at the graph of f, as it says. So what is going to happen to the graph of f when f prime of x equals 0 is what I'm wanting to know.
Can it change directions?
Not necessarily.
It's going to have a critical point.
It will have a critical point, but what's it going to look like?
Relative extrema.
It might have relative extrema.
Something crazy is going to happen.
No.
Nothing.
What do we
crazy.
get? What do we get from the derivative? Slope.
So it's going to rest.
So it's going to give us
Tangent
the
line.
slope.
What about the tangent line?
It'll be
It'll
at that
intersect.
point.
Tangent line is the x-axis. That's what you're not telling us. Nope.
I
We have some more.
about this.
Alright, so critical point happens when f prime of x equals 0. And we said we get what from the derivative? We get slope from the derivative. So what is my slope if f prime of x equals 0?
0.
0. So what is going on my graph if my slope is 0?
Horizontal. Slope is
What is horizontal?
f of x.
F of x.
No.
f prime of
F
x.
prime of x. Something is horizontal.
Thank you.
Tangent line.
Thank you. The tangent line is horizontal.
Is the tangent line down?
Because my tangent line is horizontal when my derivative has a slope of 0. So I have a horizontal tangent line when f prime of x equals 0.
I'm not
So
sure.
isn't
I
it-
shouted it out somewhere.
Isn't a tangent line f prime of x?
No. You use f prime of x to get the slope of the tangent line.
Okay. Can you do this without numbers?
What do you mean?
Can you do it graph? I mean,
Yes. We're getting ready.
Get
We're getting ready to identify. So, of the 8 graphs I have up here, when does f prime of x equal 0? Of the 8 graphs that are up here for f of x, when does f prime of x equal 0?
A through C. No, A.
It's the x-axis. Just saying.
A.
A, I agree with A.
B.
B, I agree with B.
C.
C, I agree with C.
D.
D.
E.
E, I do not agree with.
It's
Bless you.
F.
F, I do not agree with.
G.
just the top.
Not G.
It's just a.
It's
It's not H.
I mean,
It's just
look
the
at
top
it. There's
4.
a
Because there's a
horizontal line.
horizontal.
There's a horizontal line at that spot, and there, and there, and there. Those are the only ones that have horizontal tangent lines. Okay? So this is what your graph is going to do whenever f prime of x equals 0. It's going to look like, what can I describe A? Don't think about just that part. What's going on? What's going on right here?
Stevenson.
It's not an absolute.
Relative
It's
max.
actually going to be a relative max. And we'll talk about why it's a relative max here in a second. What's going on B? This is a relative minimum. Okay? What about C? This right here is actually called a point of inflection. How do you know that word already?
You said it.
like
I did?
50
Yeah.
times.
Okay, these two are actually. I said point of inflection?
Yeah.
Not today.
Not
But you were
today.
like, it's not
Oh.
important yet.
Okay. Yes, we're gonna get to
Talk about
points.
it
We're gonna get to
all the
points of inflection tomorrow. But yes, these two are points of inflection. Okay. So if I have a horizontal tangent line, or my f prime of x equals 0, it's either going to be a hill, a valley, or points of inflection. Hill or valley or points of inflection are going to happen when f prime of x equals 0. Hills, valleys, or points of inflection. Those are your three options when f prime of x equals 0. Your graph of f is going to be one of those three things whenever f prime of x equals 0. Hills, valleys, or points of inflection. That's what's going to happen when f prime of x equals 0. Okay? Now, the other one is when f prime of x is undefined, and hopefully
G and H.
we can understand that that's going to happen at E, F, G, and H.
Why is it happening at F?
So why is f prime of x undefined at E? There is a vertical tangent line, that's why f prime of x is undefined there. What about F?
Sharp turn.
There is a sharp turn, that's why f prime of x is undefined there. And what about G and H?
Vertical tangent.
Vertical tangent line.
There's a vertical inflection.
Those G and H happen to also be points of inflection.
What did you say there, Ernestine?
Because I have a vertical tangent line.
The limit of the derivative.
So, If f prime of x is undefined, what are my options?
Sharp turn.
There's going to be a sharp turn, or there's going to be a vertical tangent line. So that's graphically what f is going to do whenever f prime of x is undefined. So to back up, when f prime of x is equal to 0, what are my three options? I'm going to have a hill, I'm going to have a valley, or I'm going to have a point of inflection. What are my options when f prime of x is undefined? There's going to be a vertical tangent line or a sharp turn.
Does a sharp turn make a vertical tangent line?
No.
What's that little line coming from it?
Which one are we talking about?
Yeah.
Like at the
No, that's just identifying that that's where E is at. That's where F is at. That's where G is at. That's where H is at. That's all that's identifying.
Okay.
Is B supposed to not match up, or is that just an accident?
That's
Actually,
bad. Whoever I stole this from, they did a bad job on that.
Maybe we can still do good stuff for it.
All right, so now
They not prepared themselves to get that. Get some quality stuff.
we want to go back through. We've already identified that every one of these is a critical point. Okay, for one reason or another. What are the two reasons?
Equals 0.
Derivative equals 0 or
Undefined.
derivative is undefined. Now we want to go through and identify whether or not they're relative mins or relative maxes. And we already discussed that A was a relative max, B is a relative min. What about C and D?
Point of inflection.
Those are points of inflection, which we'll talk about more tomorrow. Okay, what about E? E is a relative max, F is a relative min, and then G and H are points of inflection. So
Supposed to know when it's relative or absolute.
we'll get to that here in a little bit. So we need to go back to A and B and E and F. Because what were A and E?
Relative
Max.
They are relative maxes. So let's talk about why those are relative maxes. Why are they relative maxes?
Because they only go up to a certain point and then they come back. And then
Here's my question. What is my graph doing on the left side of A?
Increases.
Increases. What's it doing on the right side of A?
Decrease.
Okay, down here on E, what's it doing on the left?
Increase.
Increasing, and on the right?
Decrease.
So it's a relative max because
Increases.
Increase on the left.
it changes from
Increase in
increasing to decreasing. And we'll get to what you're talking about here in just a second. Okay? Then B and F, we're both what? Minimums, because on the left side, what are we doing? Decreasing on the left side, and on the right side we are increasing. Okay? Now let's come over here to these other four and talk about why these are not relative maxes or relative mins. What's happening on the both sides of C? They're both decreasing on both sides of D. Both increasing. G, both increasing, and H, both decreasing. So those aren't relative extrema because I'm not changing from increasing to decreasing or decreasing to increasing. But in calculus, what can we not do?
That's true.
Extrapolate.
That's wrong.
We just justified that I have relative maxes and relative mins using what? Increasing and decreasing, but what were we talking about? What function were we talking about?
F of X.
We were talking about f of
We don't
x.
use something to talk about itself.
We don't use something to talk about itself. So I cannot use f to justify whether or not it has a max or a min, a relative max or a min. So that means we need to figure out how to use what? The derivative to justify a max or a min.
This is where I fell wrong.
So, if, back here on A, we said the left side was doing what? Increasing. If I'm increasing on F, what am I doing on F prime?
Decreasing. It's positive.
I'm positive.
Oh.
If I'm decreasing on F, what am I doing on F prime? Negative. I'm negative. So I am going to justify a relative maximum using the first derivative by saying my first derivative does what? Changes from positive to negative. I can't just say change sign because I have to determine whether or not it's a max or a min. Okay, so both of these two right here, derivative is positive on the left and negative on the right. Now on B and F, on the left side of B, what's my function doing? Decreasing, which means my derivative is negative. And on the right side, my function is increasing, which means my derivative is positive on both of those. So we're going to justify a relative minimum by saying what?
F of X.
F prime of x changes from negative to positive. That's what's going on there. Okay? And that is going to be a stamped justification because it does not change. If you're going to tell me something is a relative maximum, how are you going to justify it?
That is positive.
F prime of x changes from positive to negative. If you're going to tell me something is a relative minimum, what are you going to tell me? F prime of x changes from negative to positive. All right. So now we've got to change our mental thought. Okay, what have we been looking at? What function have we been looking at? We've been looking at f of x. So we now want to do all this just by looking at f prime of x. So turn the page over.
We need to fill out the box.
Well, you should have been filling out as we were talking.
What goes in, like check marks?
Put check marks on what's true, yes. So everything should have a check mark on critical point. The only ones for relative maxes were A and E, and the only ones for relative minimums were B and F. B and F for the relative minimums, and A and E for the relative maxes.
This stuff gives you goosebumps. This gives you goosebumps.
This is good stuff.
Awesome.
Alright, so now that we've turned the page, which function are we looking at?
Prime of X.
We're looking at f prime of x. Okay? So,
Do these go with the graphs on the front?
we're looking at f prime of x, and we are looking at finding relative extrema. Before I find relative extrema, what do I have to find first?
No, you have F of X.
Critical point.
I have to find critical points. Because relative extrema can only happen where?
It's already
At
said.
critical point.
At critical points.
Zero.
Relative extrema can only happen at critical points. Does that mean every critical point is a relative extrema?
No.
No. But if you're going to tell me something is a relative extrema, it has to be at a critical point. Okay, just like something, if something's differentiable, it first must be what?
Continue.
Continuous. Okay, but just because it's continuous, does that mean it's differentiable? No, same thing here. If you're going to tell me something's a relative extrema, it first must be a critical point, but just because it's a critical point doesn't mean it's a relative extrema. Same situation.
Squares and rectangles.
Sure.
Apples and
Okay.
oranges. You just said
Alright, so if I'm looking for relative extrema, I first need critical points, and if I'm looking at the derivative graph, what am I looking for to get a critical point? Where the graph is 0 or where the graph is undefined. So what can you talk to me about A? 0.
The slope is
Slope
6
is
equals 2. Or y.
What are you asking?
Yeah.
No proof of
No,
Tell me
it's
why.
never 0.
because f of x is 0, so
So you're not looking for a zero slope?
Remember, you guys are confusing yourself. You guys are thinking about the graph of f. What graph are we using now? F prime of x.
It's never 0.
Okay, there are only 4 things we're going to use f prime of x for when we're talking about f of x. What are we going to be looking for? What 4 things? When it equals 0, and graphically, what's it going to be if it equals 0?
It touches it.
It's going to touch the x-axis. So that's the first thing. I'm looking for where the graph of f prime of x touches 0. What else am I looking for? Where the graph of f prime of x is undefined. What else?
What is that? Is it a vertical line?
We'll get there. Where my graph is positive and where my graph is negative. So if I'm looking at the graph of f prime of x, and I'm wanting to talk about f of x, those are the only 4 things I'm looking at. Where it touches the x-axis, where it's undefined, where it's positive, and where it's negative. Okay? So in this case, why are there no critical points?
Doesn't
It doesn't touch the x-axis and
It's not undefined.
it's not undefined.
What makes it undefined?
Say it again.
Vertical.
We'll get there. We'll get there.
whenever it's
You'll
vertical.
see an example here in a second. Okay? So the other 2 things are, is this thing positive or is it negative? It's positive. So what does that tell me about f? It is always increasing. Because f prime of x is always positive. Now, you don't have to write that down. I'm just wanting you to think about that.
So f of x is
Still on it.
always increasing.
F of x is always increasing because f prime of x is always positive. Okay? So you don't have to write that down. That's something you need to be able to process. Alright, so let's look at B. I'm looking for relative extrema, but before I look for relative extrema, I first have to find critical points, which means I'm looking for where the derivative is 0, which means I'm looking for the derivative doing what? Touching the x-axis or undefined, whether or not it's undefined. What do I have? Either one of those in this case? Yes. Which one do I have? 0. So I'm going to say there's a CP at x equals 0. Somebody knocking?
No,
I didn't know if it was a wind or not.
good to justify.
I think it's the wind.
That's 1.
No, you don't need to justify the critical point, but when we do a relative max or a relative min, then you got to justify it. So now that I've identified it, if it's a critical point, I need to figure out, is it a relative max, is it a relative min, or is it neither? So what do you guys think?
Neither. Relative.
Always positive.
Relative. Something.
It
It's
says
actually,
minimum.
it is actually a relative minimum.
It goes from negative to positive.
Okay, remember, there's 4 things we're looking for on our derivative graph. Where it touches the x-axis and where it is undefined. So we've already done those 2. I've taken that out of the way. So what are the other 2 things we look for? Where it's positive and where it's negative. Okay? This area right here is what? That area is negative, and this area is positive. So what is my derivative doing at x equals 0? It is changing signs. It is changing from negative to positive. So we're going to say it's a relative minimum at x equals 0. And what's my stamp on a relative minimum?
It's changing from negative to positive.
There you go. Because f prime of x changes from negative to positive.
You don't put because f of x just increases or decreases.
Remember, I can't use f of x to talk about f of x.
So we're looking at f of x and f prime of x and describing f of x.
I'm looking at f prime of x to talk about f of x. Okay? So I have a critical point at x equals 0 because f prime of x equals 0 there, and it's a relative minimum because f prime of x changes from negative to positive. That's fine.
So when we're always justifying we're gonna use negative or positive, even if we're looking at the f
Same thing.
of x.
You're not going to be looking at f of x trying to find something about f of x. Yes, I might do that. I might give you f of x and then you have to tell me something about f prime. That might happen.
Will we still use negative or positive?
Yes. Alright, next one.
I don't know what you're talking about.
Alright, C. I have f prime of x equals 0. I'm interested to see whether or not this has any relative extrema. But I first must figure out what? Critical points. Does this have any critical points?
Yes.
Yes, where? At x equals 0. Now I must determine whether or not it's a relative max, a relative min, or neither. Brock, what do you think?
Relative max.
Brock says it's relative max. Why?
Am I right?
No.
No, I'm not right.
Because it looks like
It's
it
no, it's not.
It doesn't.
It's not.
Alright. Erica says it doesn't change. Remember, after I determine whether it's 0 or undefined, the next thing I'm looking for is negative and positive. And this whole thing is what?
Negative.
Negative. Which means it's not going to be a relative max or a relative min because I do not change signs.
Really throws me off.
So what does that mean it's going to be? It's going to be a point of inflection, yes. And we'll get to that tomorrow.
But for right now, just leave it.
Right now, I just want a critical point at x equals 0, no relative extrema. No relative extrema.
Is there an abbreviation for extrema?
Nope. Alright. So D. Critical points on D.
X equals 1.
X equals 1. Is it a relative max, relative min, or neither?
Neither.
Why?
Because it's all negative.
Because f prime of x is always negative. So what does that mean about my function?
No relative.
It's always decreasing.
It's always decreasing. Very good.
Size and function.
Alright, next one. Third page. Alright, Alex. Critical points on E.
Well, we're talking about with D, 1 and 4. I'm pretty sure this might be
Negative 4, negative 1, and 4. Everybody okay with that? Alright. Now what, Alex?
Now, we have to see if it's changing signs or sometimes,
Yes, or negative, positive, either one. So I need to identify if any of that is happening at those 3 spots. So that means minimum.
And then at a negative one there, it changes again from positive to negative.
So that means it is
What is,
It's a maximum,
okay,
because it went from positive to negative,
okay.
and then 4 is minimum. That is from, because, alright, so I've got 2 minimums, and I want to say both of those at the same time. So I have relative min at x equals -4 and 4, and what's my stamp justification?
Because it changes from.
What does
That's fine.
f prime of x
Sometimes I say
changes
negative
from
to positive.
negative to positive. Alright, the other one, relative max at x equals
F
Well,
of X,
negative
there's a
one.
-1, and my stamp justification,
F
Because.
prime changes from
there it is, very good.
Not getting those goosebumps.
You done?
Nope.
Are you sure?
Alright, Samantha, talk to me about F.
shoot.
Shoot.
Because it's gonna complete -4 and 1.
I agree.
I can
Then you have to look at the extremas, and it changes from negative to positive at -4, so that's a relative minimum. And then it doesn't change the rest of the thing.
Alright, so it's a relative minimum at x equals -4 because f prime of x changes from negative to positive. Nicely done. Alright, Rock. G.
critical point at x equals 0. Relative min at x equals 0. Because x changes from negative to positive. F prime of x changes from negative to positive.
Outstanding.
Oh yeah, did you buy stickers, customer?
Dadgummit, I forgot. You're supposed to text me.
I thought we were supposed to
It was a strictly a math number, I thought.
That's a math deal.
I got you.
Stickers on
Stickers are math too?
If it's math related,
I can bend
We're
you
good
if
with
it's math.
Got you.
No, you're
That's
right.
alright, H. Chelsea, H.
There's a critical point at x equals -4 and 3.
I agree.
There is a relative minimum at -4 because it's changing from
Oh, whoa.
what?
You said it badly.
You said it.
Because f prime of x is changing from negative to positive, and there's a
Where's the
relative
door coach what?
Keep going.
there's a relative max at x equals 3 because f prime of x is changing from positive to negative.
Very good. Nicely done.
They're screwing with me.
Alright, then the last page. Janine, your turn. Yep, A.
I'm so sure there's something.
Critical point at -1.
At x equals -1. Alright.
And there is relative max,
Relative max at x equals -1 because.
because f prime x changes from positive to
Very good. Very good. Harrison, I left the best one for you. B.
B.
Like,
B, D,
B.
B. Is that line in the middle part of the graph?
It's showing you that it's not part of the graph. It's
It's like
asymptote.
Say.
Yeah.
Alright, there's critical points at 1,
you have to write all these down.
5, 4,
1.5.
Okay, and 2.5.
and 2.5. Is that it?
Is that middle thing a line?
It's an asymptote.
Okay, so
No what?
no more critical points.
You're wrong.
Oh, critical
Two,
point at 2
because
because
it's
it's
undefined.
undefined.
Critical point at 2 because f prime of x is undefined. That's correct.
Forgot about that.
Yeah.
Yeah.
Maybe you should have done more studying.
So, now we need to identify whether or not those are maxes or mins, or neither. So what do I have at 1.5?
Those goosebumps.
6
Relative max at 1.5 because
changes from positive to negative.
f prime of x changes from positive to negative. Alright? What about 2?
I don't know.
You
No.
don't know. Anybody want to help him on 2? Max, min, or neither?
Neither.
Why?
Undefined.
That's a bad answer.
It's a hole.
Because it's
It's
a
a
verb.
hole.
Doesn't change signs.
Bad answer.
Shark turn. Shark turn. Jump. Hole.
F prime of x does not change signs. What is it on both sides of 2?
Positive. Negative.
Negative. Why is it negative, Rob?
Because it's below the x-axis.
Because on both sides of 2, we're down here, which means both sides of 2 are negatives.
So is it both
Both
sides
sides.
closest to 2? Because
Yes.
technically-
Both sides right next to it. Yes, both sides right next to it.
That's bad.
So what does that mean it is? Graphically.
Asymptote.
Graphically, what's going on at 2 of the actual function?
Vertical tangent.
It's a vertical tangent line. Very good.
That was courtesy of Logan.
Alright, what about 2.5?
Means
Minimum because
F prime of x changes from negative to positive.
f prime of x changes from negative to positive. Very good. C. Let's see, whose turn it is? Pauline, C.
It's, critical point at 0. Is that it?
Yes?
Okay.
What is it?
Neither.
Neither, because
F prime of x doesn't change signs at that point.
alright, so what can you tell me about f of x? What was that derivative tell me about f of x?
It's a vertical tangent line.
No.
Keeps it never decrease, right?
Never decreasing, it's always increasing.
Is it because it's above x?
So it's above the x-axis, that's correct. Okay, what would that be though?
What?
It's gonna be a point of inflection.
Why is that a inflection, but the other one wasn't?
Which one?
It
was.
B, it was?
It was a point of inflection.
Okay, that's what.
But we also know that it was a vertical tangent line. Okay, why is this one a point of inflection but not a vertical tangent line?
If it touches the x-axis.
And what does that mean if it touches the x-axis?
F prime of x equals 0.
And what does it mean if f prime of x equals 0? One more. One more.
Relative minimum maximum. Gosh dang it, I don't know.
It's a.
There you go. It has a horizontal tangent line.
I was so
Very
close.
good. Very
So
close, bro.
close.
That was the first thing.
Very close, bro. All right, last one, D.
Wait, is that only like one?
C is just a critical point. That's it.
Point at
Okay.
0, 4.5.
Critical point at 0 and 4.5. Anything else?
Not at 1. It's a trick.
It's a trick.
It's
Why
too
not?
simple. It's too simple.
There's a jump.
It's not undefined.
It's
And
undefined.
since it's not continuous,
Actually, wouldn't it be
continuous.
undefined since there's the point?
This
in
is
the
F prime
hole?
of x. This is F prime of x, not F of x, so it would be discontinuous. That's the trick.
It's not.
So, question of the day is 1 a critical point and why or why not?
How could it's not touching?
Because it's not. It doesn't touch
there's a
0
jump,
and
so the
it's
limit
not
of the derivative is not
undefined.
Why is it not undefined?
Because it has a function value.
It has a function value. Very good. So 1 is not a critical point.
I told you it was a trick.
What would make what small change could I do to this graph of f prime of x that would make it a critical point?
Erase
Yeah,
the inside
open
of the
a hole.
Yes, make this an open hole. So if I made that an open hole, then it's a critical point. But since it's got a hole, that means it's actually defined and it's not a critical point. Tricky.
I said,
So what's going on? What's going on at 0?
Relative
Relative max because
Positive,
is
negative.
F prime of x is
f prime of x changes from positive to negative. What's going on at 4.5?
Relative max.
It's also a relative max because
Well, positive and negative.
it changes from positive to negative. Now, let's assume, just so you guys will know what to do when you get to it on your assignment, let's assume this was an open hole. And if it's an open hole, that means this is a critical point.
Yeah.
And if it's a critical point, is it a relative max, min, or neither?
max, then
It's a minimum. Why is it a minimum
It's
here? It's,
supposed to be negative,
Negative on the left, positive on the
it's
right.
negative on the left and it's positive on the right, which means it's got to be a relative minimum.
that's okay.
Good. Harrison's all about.
So is that actually relative then, or just hypothetical?
This is big.
If that dot wasn't there, it'd be a relative minimum.
Oh,
Okay. And here's another question.
okay, crap.
Let's say that dot wasn't there, and I know it's a relative minimum. What would it look like?
On
On like
FX.
Yeah, on f of x, what would it look like?
A valley.
It wouldn't be a valley. Why would that be a valley?
It'd be a hill.
Be like that. Would it be a sharp turn?
It would be a sharp turn. Why would it be a sharp turn?
The limit of the derivative.
There you go. Because what is? F prime of x is undefined. Therefore, your only two options are
Vertical
Sharp
tangent
turn.
line.
a sharp turn, or vertical tangent line. And if it's a vertical tangent line, it's not a relative extrema. In this case, it's a relative extrema, so that means it has to be a vertical tangent, or a sharp turn.
That just blew my mind.
Very good. All right. So critical points.
I still know.
Kaylee, where do we get critical points from?
When F
Fun Kaylee.
So,
I know there's somebody that
When f prime of x, when f prime of x equals 0 or undefined. All right, Justice. When my derivative equals 0, what are my three options graphically? Very good. Hill, valley, or point of inflection are my options. All right. The other thing is when f prime of x is undefined. Alex, what are my two options if f prime of x is undefined? Vertical tangent line, or there's a sharp turn there more than likely. No, very good. All right. So how do we justify relative max?
when F X.
wait, what?
Addressing people.
F prime of x. So when f prime of x changes from positive to negative, it's a relative max. When f prime of x changes from negative to positive, it's a relative minimum.
It's really
Good
hard.
lord.
Very good.
Really hard.